Okay, so let's now start with example 2. Go ahead, take a few seconds, look at the table. So basically, Mr. Harkins wants to pick 2 tickets. As I'm reading the problem, something that really sticks out and is very important to highlight is the fact that he wants to select these tickets without replacement. The fact that this is without replacement now, we should be thinking that these events are going to be dependent. All right. So I'm going to use the following notation. I'm going to let event FC represent the fact that it is the first ticket picked is Christos, and SC represents the event that the second ticket picked is Christos. All right, so now using our dependent formula with the multiplication rule, let's set it up using this notation. So I want to calculate the probability that the first ticket is Christos and the second ticket picked is going to be Christos. And that is equal to the fact or the probability of picking the first ticket to be Christos multiplied by the probability that the second ticket is Christos, given that the first one was his. Okay, so let's substitute now what we know. So if you add up all of these tickets, there's actually 23 total tickets. Okay. So Christo has 5 of the 23 tickets. Now, because again, this is without replacement, I am not going to pick or put back, I'm not going to put back the ticket. So now Christo has 4 tickets out of a total of 22. All right, and again, this is going to give us the probability of the first ticket being Christos and the second ticket being Christos. So now if you simply put this into your calculator, we are going to get a percentage of approximately 3 95/100. So almost 4%. Okay, let's move on now to example 3. So basically, Kate has created a game. A winner is determined by the fact if 2 even cards are selected. Again, we want to make note that this is without replacement of the first card. So again, we're going to use that dependent formula. Another thing that's good to know is that face cards are not going to be considered even or odd. So basically, the only even cards that we can deal with are going to be card numbers 2, 4, 6, 8, and 10. And since we have 4 of each, this really results in 20 even cards. So this is definitely something we want to keep in mind. As far as setting up the problem, I'm going to let FE represent the fact or the event that the first card selected is even, and then SE is going to represent the event that the second card selected is even. So once again, let's set up the problem using our notation now. So this is going to be equal to the probability that the first card selected is even times the probability that the second card selected is even, given that the first card selected was even. So once again, like before, let's substitute what we know. So as I explained over here, We have 20 even cards out of a total of 52 cards from a standard deck. And that will get multiplied by, well, now I'm going to pick one even card and not put it back. So now there is 19 out of a total of 51 cards. There we go. So again, simply put this into your calculator, reduce a little bit if you'd like, but we're looking at about a 14.3% of this happening. All right, I hope everything's going well, and let's move on. So I've created some extra examples. So let's say we have a bag that contains all the letters in the alphabet, only one tile or one letter from the alphabet, so there are no repeated letters. What's the probability of selecting 3 vowels without replacement? So there are going to be 5 vowels in total. So let's start with that. So 5 vowels out of the 26 total tiles, but now I picked one of them and I am not putting it back. So now there's 4 out of 25. And lastly, because I want 3 of them, I better pick one more time, and now it's 3 out of 24. So I just wanted to kind of give you guys something a little different, something to think about. And if you did it correctly, you actually get a fairly small decimal. So you get less than 1% of a chance of this occurring. All right, let's try one more before we try the PBT. So what if I have the same bag of letters? And what is the probability of selecting 3 vowels now with replacement? So it's definitely going to change the problem a bit. So again, I'm going to start with 5 vowels out of 26 letters times, oh, but you know what? I picked one and I put it back. So it's going to be 5 out of 26 again. And you know what? Again, I was able to put it back. And there you go. So just multiply all that together. Still a very small percent, but slightly larger than what we got in the above case. All right, I hope you are liking these problems and understanding them. Let's wrap it up with our PBT. So this is on page 81. Go ahead, take a few seconds and read it. So basically the problem is asking which set of cards is harder to draw? 2 cards that are hearts or 2 cards that are 8s? So really another way of calculating this is which one is going to give us a smaller probability, because the one with the smaller probability is going to be much harder for the event to occur. So a smaller percentage or probability results in being harder or more difficult to draw. All right, well, I want to basically calculate the probability. Let's not write in highlighter mode. Let's try this again. So I want to calculate the probability of picking a hearts card first, and the second card being a hearts. Okay, and we should, let's see if we reread the problem. Okay, we should probably treat this as an independent event. So I am actually going to delete that. All right, so we want to calculate the probability of picking first a hearts card, and then times the probability of picking a second hearts card, given that the first one was hearts as well. All right, well, we have 13 of each suit, so we have 13 cards with hearts on it out of a deck, standard deck of 52. But now I'm going to take one, not put it back, so it's 12 out of 51. If I calculate this, I'm actually getting about a 5 88/100ths of a percent. So let's kind of repeat the process, but now I want to calculate the probability of picking an 8s card first, and then picking second another 8s card. Whoops, there goes my pen. So this is going to be the probability of the first card being an 8 times the probability of the second card being an 8, given that the first one is an 8. Okay, well, we only have 4 cards with the number 8 on it out of a deck of 52. Times, well, if I picked one and I'm not going to put it back, making this a dependent event, now I only have a chance of 3 out of 51. So I think you can kind of already tell we're going to get a smaller answer here, since conceptually it should make sense, right? There are less cards with an 8 on it versus cards with hearts on it. So this is giving us a very small percentage of 44/100ths of a percent. So if we compare the two, the probability of getting 2 8 cards is much less than the probability of getting 2 cards with hearts on them. So for this reason, therefore, we should be able to conclude that it is harder to draw 2 cards that are 8s. All right, well, this actually brings us to the conclusion of our lesson. Again, if you need to, feel free to watch this again or go visit your teacher and ask some questions, or of course go to Math Resource. Probably for the most part, this will be your homework assignment on page 83 through 84, problems 1 through 10. Most likely the problems 1 through 8 will be without replacement, but if you want to just confirm and ask your teacher, maybe do so. All right. Here are some worked out solutions. Again, I know that you have answers in the back of your book, but I'm sure it helps to have some worked out solutions. Okay, thanks, and good luck with this unit.